Good evening, YouTube. This is Die Fish. This is the magnesium electrode that I had in my cell number 5 that I was not able to insert the electrode all the way down. So you can see here is where the magnesium electrode was in the molten salts. This is where the magnesium was in the molten salts, where the copper was adjacent to it. Now, this is somewhat interesting. I'm not seeing pitting per se, but there's definitely a difference in the oxide. I have not scraped this to the bare metal, but I'm just noting there's a differential in color. Now, if I take this copper electrode and if I place it on the area down here, you're getting about that voltage, right? Place it here, a little bit higher voltage. Susceptible to movement more so. If I stop moving it, the voltage goes away. Again, you can tap it. That infinite thickness is there. Now, I'm going to show you something interesting. I don't know how much volume of salt crystal at this type we are going to need. So, I'm just going to take an infinitely small drop of water on this spot here and this spot here. So, I'm going to place one tiny aliquot of water here. Okay, there you can see it. And place another small aliquot of water here. So you see the two water beads or so thereabouts. Now, what I'm going to do is we're going to take the electrode and I'm going to test it first here on the area that was not originally touching the copper electrode, and let's see what the voltage is. So, sort of fascinating. Sort of bouncing all over the place. But it stabilizes to about 1.3, almost 1.4 volts. Now I'm going to do the same thing. I'm going to place the copper electrode on this area here. And there's the voltage, which is almost the same exact voltage that I had with an infinitely greater amount of salts. So again, we have an infinitely thin adherent layer on both surfaces. And if I take a blade, and I'll just wipe off this water here. Again, this does not scrape off. You know, I've rubbed towels on this. I'm rubbing my finger on it, and that oxide layer that is on the magnesium here is not coming off whatsoever. Nor does it come off here, even after rubbing it. So, let's take an X-Acto blade to it and see if we can see if it comes off easily or how adherent it is. So, please forgive my shaky hands here as I try to scrape this, but there's the bare magnesium. That oxide layer is fairly tenacious, so I don't believe that there's any type of pitting per se, but placing the magnesium into the molten salts definitely deposits a layer on the magnesium that otherwise may not occur if we heat it up at the same rate. So again, by scraping this, you can see it's a pretty tough layer. I have to scrape pretty hard to get this material to come off. I have to scrape really hard actually to get this adherent layer. And you can see the oxide or whatever salt interstitial layer there on the magnesium. So this material here did not seem to pit this from what I'm looking at, but it did form an extremely tenacious layer of material. And let's take a look at the other side here now. Camera to focus, okay. And this is the area that was not adjacent to the copper. And again, it's a tenacious layer. I'm scraping it pretty good. I really have to apply a heck of a lot of downforce to get her to pull up a chip. But suffice to say, placing the magnesium into the molten Epsom salts alters the surface of the magnesium dramatically. And this infinitely thin layer seemingly is all we need to make the battery. So having all the extra stuff may not at all be necessary. So for what it's worth, have a good evening.